So in Module 10, we're going to talk about vSphere DRS. As you scale out your vSphere environment, you need to be aware of vSphere features and functions that will help you manage the hosts in your environment. DRS is one of them. By the end of this, you should be able to describe the functions of a vSphere DRS cluster, should be able to create a vSphere DRS cluster, view information about the cluster, and remove a host from the cluster. DRS stands for Distributed Resource Scheduler. We got some prerequisites to fully utilize DRS. The big one is vMotion, and of course, in order to do vMotion, we need shared storage. The reason is DRS is going to move the machines to hosts that can better suit that virtual machine, and it's going to need vMotion to move it to a different host. We can configure the automation level of where the initial placement of the virtual machines are going to be. We can have it be fully automated, manual, or partially automated. We can also use predictive DRS. When this is enabled, it uses statistics from the host, or if you're using vRealize operations server, it'll use that statistics from it to say, hey, you know, you may be getting ready to, may have to run DRS at the load you're running. You know, it's coming up, your load's growing. We predict that based on these statistics, you're going to have to move some virtual machines, or you're going to start having some resource contention. You can also change your virtual machine swap file location. You can have it defaults to the virtual machine directory, so wherever that virtual machine lives is where the swap file is going to be. You can move it to a different one again, and it tells you in this little arrow right here all the hosts that it's going to move to will need to be able to see that data store so it can utilize the virtual machine swap file. One big benefit, probably not as big as it used to be, but you would move these swap files to, let's say, SSD cache. Nowadays SSDs are a lot cheaper, so you know you may be running the VM already on an SSD. But that was a big benefit back in the day. Is I got a few SSDs. I'm going to put them in there, and I'm going to use it for my swap files. So when my virtual machine is swapping, it's going to be a lot faster than on a mechanical drive. We can also use DRS for virtual machine affinity, and we create affinity rules. What that does is, in this example, these two virtual machines, we may not want them to run on the same host. Maybe they cause they're big resource hogs. So, and an example is databases, which could be, I want these to run on different hosts, so I would separate them. We can also have DRS groups, and this will be the same way. We have database servers, and in this example we have two servers in that group, and then based on, we would apply affinity rules to that group, either separate them, or it may be a licensing issue. We want to keep the databases together because we have processor licenses, and we don't want to have one host covered, so we want our databases to run on one server. You can also have a host group to where we have ESXi hosts that are part of that group as opposed to a VM group. Now, a virtual machine and a host can belong to multiple groups. In our affinity rules, this is on this example, we would set it, we want the VMs run on different systems, and the type is virtual machines, the host, and we have our group, which is group A. It should run on host in group B. So we may have certain ones we want databases to run on these hosts because they have more processors, more memory. We want those to be in group B, that we want these databases or whatever we're doing with these virtual machines to run on. A preferential rule is a softly enforced rule. So when we create these rules, if we don't have the resources, it's not going to do it. If we did a preferential rule that said, I would really like to have these resources available to these virtual machines or these virtual machine groups, great. If you can't find it, go ahead and violate the rule or constraint and run it on another host anyway. And then we have the required. A good example was using here, like I talked earlier, on the licensing. We don't want to violate that constraint because we'll violate our license. So therefore, these machines are going to have to run, these virtual machines, are going to have to run on these hosts because of licensing requirements. So we'll do a strict rule and says these have to run on the same hardware or in the same group that we have it licensed for. Now, and again, we can override these rules we set on the cluster setting for DRS or a group for DRS by going straight to the virtual machine, and we can give it an automation level. And as you can see, we can override that, but then like on the restart priority is going to use the cluster setting. So whatever we have defined in the cluster, we'll use that. We can add or move host to a DRS cluster. It will keep the resource pool hierarchy of the existing host. If you disable DRS, you have a potential of losing the resource, those host resource pools. So if we have a resource pool and a host, and we remove the host from the cluster, we'll lose that resource pool. We can view vSphere DRS location in the Summary tab. And as you can see on this one, it's showing us a perfectly balanced host. And it gives us the CPU, in this example, CPU utilization of both the host and that cluster. Also on the DRS tab, when it shows us the information, we can look at recommendations to maybe you need to move this machine to a different host. We can see any faults that's happened or any history. We can also, clicking this button, the Run DRS Now, it's going to say, okay, let's look at the environment now. This is what was happening earlier, and this is our recommendation or what we did. So I want to run it now, and let's see where we stand. And then if I want to apply those, I can apply all the recommendations, or we can override it and choose which recommendations we want to do. We can monitor it in task and events. That'll tell us that DRS powered on a machine, moved the machine, whatever it did. But as you can see in this example, it'll say DRS powered on mail server 01 on host ESXi01. So we also want, let's say we want to do some hardware maintenance on one of our hosts. We can put it in maintenance mode. That will render the machine, not the host, not to take on any virtual machine operations. You also have the option it will evacuate the virtual machines, which means it will vMotion over to another host. That way we can take that machine out, upgrade memory, do some hardware maintenance, whatever we got to do with that host, and then it won't affect the load of our cluster. We also can use DPM, Distributed Power Management. What that will do is, let's say I have a larger cluster than I'm actually using with VM loads. Great example, AWS was created. They had this huge infrastructure, and Amazon only uses it in their peak business times, but for the rest of the year they're not using it all. If we had a cluster such as that, to where we have peak times of the year, we need the hardware, but we don't really need that hardware to be powered on 365 days a year. We could use distributed power management to turn that machine off. Now, when our cluster starts getting utilized and we need more hardware, it will send out a command to turn that machine on, that host. The host will come on and then start servicing virtual machine operations. Now, before you remove a host from the DRS cluster, you need to consider, we need the resource pool hierarchy to remain in the cluster, if you do. Because the machine will need to be in maintenance mode, all the virtual machines will be powered off, or must be. You may have to do it manually, depending on the machines. And the resources available for the cluster will decrease. You can turn off DRS for a cluster. If you disable it, the resource pools are removed from the cluster. When it's disabled, the resource pool hierarchy and affinity rules are not reestablished when you turn it back on. So when you turn it off, it deletes that information. If you want to avoid losing the resource pools, you can save a snapshot of the resource pool on your local machine. You can also restore previously saved resource pool snapshots when you enable DRS. So it'll give you the option, you can turn it on and then you can restore your snapshot tree, or your resource pool tree snapshot. Things we can do to improve virtual machine performance methods. We can use network traffic shaping. You can modify the CPU and memory reservations. We can modify the resource pools limits and reservations. Use NIC teaming, storage, multipathing, and you can use a vSphere DRS cluster. And those are ways we can improve our virtual machine performance. Another feature of DRS that works in tandem with it is HA, high availability. But for some reasons on why HA might not be able to fail over all virtual machines, and HA admission control might be disabled, or the resources are insufficient in the cluster to power them on a different host. You may have some required affinity rules that prevents HA from failing over a virtual machine to another host. You might have aggregated resources, but they're fragmented across the host. So let's say you've got a few hosts where, let's say you needed 8 gigs of RAM to bring up a VM. You might not have it available on one single host, so that could be an issue. So you might have to manually move some machines over to get contiguous free space for memory in that example. We should now be able to describe functions of a DRS cluster, create a DRS cluster, view information about the cluster, and remove a host from the cluster.